Hi everyone, myself 𝗍𝗶𝗴, founder of MantidelLabs. For the past few months, I have been working on a very interesting project. This is MDL-26, an autonomous tracking turret designed to detect, track and attack on human target using computer vision. And MDL-26 is the first prototype built under MantidelLabs. The turret uses a webcam for target detection, a laptop running computer vision algorithm for processing, and an ESP32 microcontroller for hardware control. The system is capable of detecting human body and calculating its movements and controlling the turret's pan tilt movement. So before building anything, I started with a concept sketch. This diagram shows the original idea of how my turret should look like and how all the mechanical components would be arranged. For this project, I decided to use the gel blaster for my turret as a weapon. First, I tested the gel blaster to see how it performs. Then I measured its size to understand how it would fit to my turret structure. However, the original body of the turret had a lot of unnecessary plastic which added extra weight to it, so I decided to cut it down. Most of the plastic removed was only just a part of outer body, not the actual gearbox inside the gun. Next, I designed the pan tilt gear mechanism. Both axes use a 38-tooth gear driving the 56-tooth gear. By using this gear ratio formula, I was able to achieve 122 degrees of sweep in both axes, and it also helped me to increase the torque and precision. For the smooth horizontal movement, I used a 4-inch 𝗧𝗿𝗶𝗶𝗃 bearing mounted on 15 by 15 cm acrylic plate. This bearing supports the weight of the turret while allowing its smooth rotation. During the assembly, I ran into this problem. The plates were too closer, making it impossible to screw the second plate properly. So I solved this problem by adding 4 access holes, allowing me to tighten the screws to the holes. For actuation, I used MG996R metal gear servos. A circular servo horn is used to mount the 38-tooth gear which drives the larger 56-teeth gear connected to the turret base. To reduce the stress on the servos, I added a support ball bearing. This bearing carries the part of the mechanical load so the servo motor doesn't experience excessive stress. Once everything was assembled, I tested the pan mechanism. The turret base now rotates smoothly with the gear mechanism. Next, I designed the base box of the turret, which houses all the electronics. The box will contain components like the actual PCB of the turret, voltage meter, cooling fan, and all the power electronics. After cutting all the acrylic panels and assembling them together, this enclosure will protect and organize all the internal electronics. The base structure was finally completed. I also designed a removable servo mount. This makes it very easy to replace the servo later without disassembling the entire turret. After finishing the base, I started building the tilt axis, which holds the turret mechanism. The 2 acrylic arms hold the gun and allow it to rotate vertically. The tilt axis also uses the same gear mechanism which we used in the pan movement. The ball bearings were added to both sides of the turret to reduce the friction and mechanical stress. The tilt servo drives the 38-tooth gear which then rotates the larger gear attached to the gun. At this point, the turret structure was mostly complete. This gave a good idea of how the turret final system would look. Before adding automation, I first tested the movements manually with the joystick module. This confirmed that the both axes was moving perfectly fine. If you're wondering about the small box on the muzzle of the gun, that's actually a counterweight, which balances the webcam that we will mount later in this video. So because the turret body was made from clear acrylic sheets, it gives a very clean look after revealing all the stickers from the sheets. With the gun installed, I tested the full painted movement again. To improve the look of the turret, I painted the gun body with matte black spray paint. For the vision system, I used the 1080p 30fps webcam. This camera will detect the target and send a tracking information to the turret. The webcam was mounted on the gun and the electronic circuit was assembled on the breadboard. I also added a limit switch to the tilt axis. This prevents the servo from moving beyond its mechanical limit and getting jammed. Now let's talk about how the system actually works. The turret uses two main systems. The first, the laptop, which runs computer vision using Python, OpenCV and MediaPipe. The laptop detects human body position and calculates the aiming direction. Then it sends command to ESP32 using serial communication via USB. Second, the ESP32, which controls all the hardware. The ESP32 simply moves the servo and controls all the system. When I first tested the system, the tracking was slow and inaccurate. So I tuned the PID control parameters to improve the speed and stability. After tuning the system, the turret was able to track the target much more smoothly than the previous one. Finally, I tested the system outdoor to see how the camera performed under daylight. After the testing, I assembled the complete final breadboard circuit. This included the ESP32, a relay module, power regulation system, capacitors, LED, and all the control electronics needed to run the turret. Once the breadboard system was working properly, I started planning the final PCB layout using the 𝗧𝗿𝗶𝗴 board. This gave me a rough idea of how all the components would be arranged in the final circuit. After finalizing the layout, I started soldering all the components on the PCB board. To improve stability, I created a thick common ground backbone across the PCB. This helps reduce noise and unwanted signal problems, voltage fluctuation inside the circuit. For basic power protection, I also added a 5 ampere glass fuse near the main power input. This fuse was mounted using male adder pin, making it easy to replace later if needed. After completing all the PCB wiring, I powered the board for the first time. At this point, the entire control system was finally running on my custom PCB. Now it's time for the final outdoor testing. Before enabling the fire system, I first tested the tracking accuracy using only the laser. This helped me verify that the turret was looking onto the target constantly. Once the tracking was stable, I enabled the fire mechanism. After that, I tested the turret in multiple movement scenarios to see how well the system could respond to the different target motions. And of course, I tested this on a test subject.
ये इसका ये मैक्स एरिया है और उसके पीछे वो मैक्स एरिया दीवार की इसके पीछे ये पत्थर के पीछे
लग रही है
हाँ
नीचे थोड़ा नीचे भैया थोड़ा नीचे
वो अपने आप देखता है हम नहीं कुछ कर सकते उसको
नहीं तब नहीं ऑन करो ये गलत चीज है नहीं ऑन करो यार उसे मत करो पहले ही डरी हुई थी
सामने मत जाना इसका सामने मत जाना
कैसे इंसान हो
Even after all the improvements, one major problem was still remaining. The turret still struggles in the low light. Sometimes the webcam could not detect the human body properly. This is most likely an imitation of the webcam. But in the next version, I may solve this problem by using a better camera or a dedicated night vision system. Even though version 1 is complete, this is still the beginning. In the next version of this turret, we will focus on better accuracy, faster response and improved stability with much more. All the resources used in this build, including the source code and the component list, are available on my GitHub. The link is in the description box. And with that, the version 1 prototype is finally complete. The turret is now capable of detecting human body, tracking its movement, controlling the pentest system and activating the firing mechanism in real time. And throughout this project, I faced many problems like mechanical issues, power instabilities, servo stress, tracking lag, relay problems, grounding noise, and low light detection limitations. If you have any questions about this project, feel free to ask in comment box. I will make sure to reply all of you. If you enjoyed this project, make sure to like this video and share it with your team. And for more future builds, subscribe to this channel and stay connected. Thanks for watching.